can hear me, but how's the audio coming through? Okay, all right. Yeah, so as Matt said, I'm Kyle Wagner. I'm a software consultant here at Source Allies. Appreciate you all coming out. It's nice to have a crowd here. I'll try not to disappoint. I've been working around Python, I guess, for 10 years or so. Haven't really worked on an application that was solely Python or that was really a Python-only web application professionally, but have used Python a lot for smaller pieces of work like Lambda functions in AWS or a script that needs to run in a pipeline. I've found it to be a good go-to for that as a more approachable and robust option compared to like a bash script, which you also sometimes have to break out as needed. And Python is probably my go-to these days for just trying things out on my own, I find personally. You'll get a lot of examples online in Python. AI has a lot of trained data for Python, so it's pretty good at producing, Python projects and so forth. So as I'm trying things out personally, I use it quite a bit too. Agenda-wise, so what we're going to talk about is managing Python versions, virtual environments, some of the tooling that is available around that. We'll talk about pyenv and venv specifically with a little more depth, going through several examples, show how that fits into a deployment for an AWS project, a very small AWS project. And then we'll talk about some of the other tools like pyenv, poetry, and uv. We'll talk about those much less, and that may disappoint some people in the audience, but there's always room for more in a version 2, or someone else can take up the torch. And then we'll leave a little time for questions. So let me get set up here with screen share. So throughout the presentation, I'll refer to a few web pages, a bunch of CLI inputs and outputs, so some kind of interactivity there, and then also a little bit of code base and VS Code. So those will be the primary apps that I'll be switching between. If you think I need to make adjustments on sizes, if something's hard to see, please let me know. Likewise, if something isn't making sense as I'm punching in a command and something comes out, feel free to raise your hand throughout or just call out throughout the presentation. We can take a closer look at that. Small groups, so definitely open to having this be interactive. I created this GitHub repo called Python Environments. It's available at github.com. kpwagner/Python environments. This might be a handy reference. It talks about some of the different environment tools, the ones that I mentioned in the agenda. And then there's also a separate README for each of those with a description, some quick starts on how to install and so forth, and then examples on different commands that are important for those tools. So I'll be referring to this somewhat over the next 45 minutes or so, but keep this in mind if you want to follow up on any of this and bring it into your own work. And if you're wondering how much time I spent developing this, it probably will not surprise you I didn't write every line in this document. In fact, I used GitHub's Copilot capability built into GitHub. So when I created the repo, it said, hey, do you want to prompt me with what you would like as a starter? And I was like, yeah, I was going to do that anyway in like ChatGPT. So prompted it, and I got to say, it produced a lot and a lot of useful stuff that I did vet, but gave me a big lift for sure. I always feel like I have to disclaim when using AI tools. I don't know. I don't know if that will ever stop being a thing. It's like, oh, hey, I did Google this, You don't have to say that anymore, but. All right, so Yeah, so what is the problem with Python that people commonly face? So when you first need to get Python on your system, maybe it's already installed. Maybe it's a version that you don't want that is already installed, but a lot of times what you'll do is you go to python.org, download an installer, it does some work, you go to your command prompt and type in Python and it works, hopefully, and that works pretty well. If you need to install some other dependencies, you do like a pip install of a library like requests, and that installs, and then normally when you're in any other directory, that will be available. If you run a script and import requests, it works, and you're pretty happy with that. But there isn't as much kind of rigid framework around Python like there is some other language / framework combinations. Like if you're working in Node, there's kind of this predetermined structure for the most part of like a package.json file, and you have your dependencies in there, and those are split out between the dependencies for your application, dev dependencies, which might include things like testing libraries, etc. And there's some other capabilities that are sort of predefined there. And Python, in its history, has not really had that, and it's starting to become more standard what you can use, but there's also a wider range of tools available to help solve this problem. So problems you have are, what if I want more than one Python version on my machine? How do I switch between versions? Depending on what you're doing, you may not care about that, and that's fine. But as you start to work across multiple different types of projects, as you start collaborating with other teams, working professionally, it becomes more of a problem that you need a specific version to match, say, a runtime of where your application will actually run. And we'll show that when in the AWS app portion of this, where matching a specific runtime matters. And then for dependency management, you want to have the ability to have specific dependencies for specific apps, meaning a specific set of libraries. And you may want specific versions of those because you may have compatibility issues between the different libraries in your application, and ultimately how it all fits together. You want to create a more predictable or dependable and predictable local setup that is going to more closely match what your application will actually do when you deploy it. So some of the tools that are available to address that are the ones that I mentioned, pyenv and venv. Those are kind of the baseline tools. They're close to available out of the box, I would say. Pip env is I would say like a modest upgrade from that, and we'll take a little closer look at that. Poetry is more complex, but solves similar problems. And then UV, I don't know how old it is, but to me it's kind of like the new thing, the new hotness. And it's known for being very fast. And generally, I haven't heard anyone say something bad about it. It seems like it's kind of the best new tool available. So I haven't really used it much outside of preparing for this presentation, but it's definitely something as the opportunity presents itself, it's a tool I'm looking to use. All right, so let's talk about pyenv to start with. So pyenv will likely not be already available and pre-installed when you install Python. So you'll have to do some kind of an installation, and it will likely be CLI based. So depending on your system and how you want to handle those, that installation, you can use brew, homebrew would be an easy way to do that. There is you can hit a URL with curl and basically run this. I think this is probably available on the pyenv website, but this will download pyenv and install it. It will probably work. You can also clone pyenv from the repository and then just have the the entry point for pyenv available, meaning when you run pyenv commands, it's just pointing to that that file on the system. And I don't know if it's a problem anymore, but I know in my personal setup, when on a Windows machine running a Linux WSL environment, I did have to clone pyenv to a directory in that WSL file system in order to get it to work at least cleanly. I don't remember what the problem was exactly, but I had problems. So be aware there's some different options, and like all of these CLI tools, sometimes you have little things that pop up that are difficult and you have to troubleshoot them. But for the most part, it's probably going to be a reasonable experience. So I already have pyenv installed on the system here. And so we'll just kind of take a little bit of a tour of what's available. So if we look at, so I'm running, version 2.68. It's, just as a sanity check, make sure it's installed and the commands are going to work. So if I run versions, this will show me which Python versions are available with pyenv. So I have 3.10, 3.11, 3.12, and 3.13, some specific patch versions of those, and only 4 different versions is what I have available. There's an asterisk next to the bottom one that shows which one is currently active. So if I run Python version, it corresponds to the version in pyenv which is pointed to as being active. Now, what is nice here is it also shows you why it's using that version. So it says set by pyenv version environment variable. We'll see in short order when and how that can change. Let's see. So if I want to change my Python version, I can use the global command, and then I can just point to a different version. So if I want to do 3.11.13, because that version is available, it ran, didn't give me any output saying that it's working, but now that didn't work. Let's see, 3.13. Let's see, let's try that again. pyenv global. Okay. That's a good question. So I thought that was removed because it's this directory. So if I do, no, I don't either. Let me change directories. Here, let's do new tab, size this up a little bit. In home directory. Yeah, there we go. So there was something going on there, not sure what. This is I didn't completely refresh the shell from earlier, so maybe there was still probably that environment variable was still set here, but then when I initialized a new Z shell, then that environment variable got set to something else. So it's basically like what Joey had said, just the version file didn't, well, there was something hanging around. So now if, let's see, now if I go back to this shell, Python version, still pointing at 3.13, but if I refresh the shell, yeah, now, all right. Well, it's a mystery to me. Okay, so just going back into the project directory that I was in before. Make sure this is big enough. Now let's try, okay. So totally new shell, and it's respecting the globally set version now. Oops, let's just take a look at the versions that are available again. And then just to check, let's reset the global version to something else, 3.12.6. And then it's pointing to 3.12.6. If I check the version of Python, it went to 3.12.6. So it is successfully switching between versions as we would expect. Let me get this sized up so it's presenting all right. All right, no plan survives first contact with the enemy. All right, so then, all right, that's great. I have 4 Python versions installed. We were able to switch between them. How do we install other versions? Oops. We can view what versions are available for installation by invoking pyenv install and then versions. Or that's not correct, it's list. Pyenv install list. So this dumps out a long list of all of the different versions of Python that are available. So you notice a lot of these are prefixed with something like stacklist, PyPy. There's PyConda, or Anaconda versions in here. I don't know how many there are a lot. So typically, mostly what you want is like the proper Python versions, just the 3.12 something. And you don't care about having a specific release that isn't like the official Python release. So let's see, I'm just gonna snag this snippet. We can filter down to just the proper versions of Python that aren't that don't have any prefixes to them, and we can see that they're mostly all available. Looks like the most recent stable release is 3.13.7. There's a dev release for 14 and 15. You can get all of those. So then to install, it's just a matter of pyenv install, drop in the version, and it will go through the installation process, and that will be available in the list. And then it's just a matter of using one version or another. Okay, so if you want to, switching between versions is great, but it can be a little cumbersome if you have to manually do that all the time. So you can define a local version of Python that is local to the directory you're in, and I believe all subdirectories. And you can do that with the Python local command. So you pass in Python local and a version. So pyenv versions to list the ones that are available. So let's set a local version here of 3.10.16. 3.10.16. Okay, and then we can see that pyenv versions is now pointing to 3.10.16. And if I open a Python shell, we get 3.10.16. So it seems to be fully respecting that. If I go up a directory to my developer directory, and then I check Python versions here, we can see that it's pointing back to 3.12.6. So 3.12.6 is the global version that is set, and so in the developer directory, it's respecting that. It's using it's using that from the global config. So if I go back into the directory I was in before, this PyWare presentation, or this Python environments directory, and then look at the versions again, it's back to 3.10.16. So why is that? And it's the reason that Joey pointed out earlier. When you run pyenv local instead of version, it creates a Python version file. And it's just a simple text file, and it has the version in it. But pyenv will respect that. It goes through some process, some hierarchy of searching for a version to use, and this is one of the stops along the way. So I believe if we modified this, it would change your local version. So it can be handy to have it in a file, though. Can anyone guess why? At least, can anyone guess the reason I'm thinking? That's a little more challenging, probably. Yeah. Persists? Uh-huh. So like persists how? Like between, like when I go back to the project later, it's still there? Yeah, sure.
Reboot, you don't have to think about it when you go into the folder. It's just set to the version that you work in.
Mm-hmm. Yeah, right on. Any other ideas on why it could be useful? Uh-huh. Yeah, right. So anytime you go to this directory, it's going to use that version. Mm-hmm. Yeah, definitely. And it's also visible, like you can see it visually here without even needing to refer to an environment variable or anything like that. Another reason that I was thinking of is that you can commit this to source control. And when you share it with other teammates, when they pull that down, you're kind of defining, we want this project to run with a specific version. All valid input, thank you. Okay, so moving on to venv. So I actually didn't know this until I was researching this presentation, but venv now ships with Python out of the box. You don't have to install it separately. That happened somewhere around one of the 3 versions, 12 or something. Let's see. So venv is a tool that enables virtual environments. And what that is it's kind of just like a box on your system to put installations of different dependencies for Python, and it isolates them within that box. So kind of like we saw where with pyenv, we go into this directory, we're on one version, we go out of it, we're in a different version. Similarly, with venv, you can create this box where you go in it and you have a certain version of requests library. You go out of it and you either don't have a request library installed or it has a different version. So let's go into the pyenv venv directory and let's create a virtual environment and see what's involved with that. So calling python-m for module, so I'm invoking the venv module, and the second, or the positional argument here is a name for the virtual environment. So you can name them whatever you want. Commonly, you see them just named venv, V-E-N-V, or .venv. I kind of prefer it without the dot, though I think it goes a little bit against convention, but ultimately you can name them whatever you want, so I'm exercising my right here. Okay, so that worked. Incidentally, we are using Python 3.10 here, and it did work. So either it ships with Python 3.10, or possibly I had previously installed this. I'm not sure. Okay, so I was in this directory of the project, and I ran the command to create a virtual environment. with venv, and it created this directory, venv. It did that because that's what I named it. So if we named it Kyle's special virtual environment, that would be the name that we would see here. So it's going to include a few different files, a config file, which I've never paid much attention to, a lib file, which I believe is where all of the new packages that you install will be, they will be shown here, and we'll see that. And then importantly, there's a bin directory, and this has different files in it that are scripts that you use to activate the virtual environment. So right now, if I call which Python, we can see that it's still pointed to basically my global Python that is managed with pyenv. If I activate the virtual environment, we'll see something different. So to activate a venv virtual environment, you call source, and then you reference the relevant script for your setup, for your operating system. So in this case, venv bin, and then activate, which is basically a shell script as far as I understand it. It doesn't have a shell shebang, but I think it's basically a shell script. Okay, so now if I run which Python, we can see that it's pointing to the pyenv venv bin Python. So it's basically pointing to this virtual environment. So this which Python command is very handy for troubleshooting when you're like, wait, which like Python am I using? Which virtual environment am I in? So that's definitely a command if you are not familiar with it, if you don't already use it, it's very useful for these situations. Okay, so let's try to install a new dependency. So if I just do pip install of requests, goes through and completes that. I'll do this the easy way. So just open a Python shell, and now if I just try to import requests, we can see that it succeeded because it gave me another prompt. So we can now use that library. It's available, we installed it. So let's take a look at the time that it doesn't work. So I moved up a directory, which Python. Okay, so I'm still, this virtual environment is still activated because which Python still points to it. So I'm gonna run deactivate to deactivate the virtual environment. So which Python is now pointed to my global again. And I'm gonna open a Python shell for that Python. And now I'm gonna try to import requests. And it's installed in my global environment. So that didn't make the point. At least I think it is. I thought I uninstalled it. All right, let's try this again. Yeah, so opening a Python shell, trying to import requests, it says no module name requests. It's not available. Okay, so let's go back to the pyenv and let's activate that. Source, venv directory, bin, activate. Okay, we're back in the virtual environment. Now let's try this again. So importing requests works. I didn't do any other installations, etc. It's just proving the point that in the virtual environment, requests is available. Outside of it, it is not. Okay, so back in the project structure, we can see that in this pyenv directory, there are a few other files, and let's like export our current dependencies that we have by running pip freeze, and we'll write that to a file. So then, looking at the files again, it wrote out the dependencies that were available in that virtual environment, which includes requests, because we installed it. Now, this requirements.txt file is available, and this can also be committed to source control, and we can use it as a point of reference to kind of switch between different virtual environments, different projects if we need to. Okay, so let's clean up this virtual environment. So to get rid of a virtual environment, to delete it, it's basically a matter of just deleting the folder that you created that represents that virtual environment. So there's the venv directory. So if I just delete it and all of its contents. Yeah, so that also effectively deactivates the environment. So it just wipes it away. And because we still have that requirements.txt file available, that's one of the ways that it makes it, it can be easy to then recreate that environment. So if we call venv, and let's just create the directory again. So directory is recreated. It does not have requests in it or any of the other dependencies that depend on, or that requests depends on. So now, I guess it's activated. I'm going to go ahead and let's see. Just activate the virtual environment again, just to make sure. Okay, so now if I pip install, and I can pass the requirements.txt file in, then it will install everything that this file defines. So now, even though we just completely blew away that virtual environment, we're able to recreate it quickly. So you can imagine if you're working with teams, like other people on your team, if requirements.txt and your Python version file are things that you commit to the project, they can then pull that project down and easily, within some reason, recreate the environment that the project is intended to be worked in. Okay. So let's see how this might fit into some AWS infrastructure. So in here, in this branch anyway, not in the main branch if you're referring to the GitHub repo, there's a CloudFormation template that is very, very small and simple. This talk isn't really about AWS or CloudFormation templates, so we'll keep this high level and simple. But basically, this is just a way to define infrastructure in code, and then we can deploy this to an AWS account. So what this has is a serverless function in it, which is a more capable way of defining, or kind of a higher abstraction layer for a Lambda function, if you've heard of those. So just a small piece of compute that can pop up and be available and then go away. So what this Lambda function has defined is a few different parameters, and then it points to a file named app. So that's just a Python file. And all this file is meant, all this code is meant to do is return a string, hello from Lambda. So I am going to hop over to AWS and just grab some valid credentials. Okay, so I'm in the pyenv venv directory. It has that template.yaml file in it. And I'm going to use a CLI tool called SAM to try to deploy this infrastructure that we just looked at. All right, and it's going through its thing. It looks like it's off. So let's go to, this is inside of the AWS account. And in AWS, there's a concept of stacks, which are basically ways to group different resources together, so different pieces of your application together into a kind of grouping. And so that's what this pyenv demo stack is. In the events, we can see it's gone through and taken several steps to create this hello function that we defined, and it completed that successfully. So looking what's available here. Oops, this is probably kind of small. Sorry. Let's get a little space here. Like I said, if the screen is small or anything, please interrupt me. Okay, so looking at this Lambda function in AWS, and if you aren't really familiar with AWS at all, I know the past minute or so has been a little bit like, wait, what's going on? And that's fine. So bringing it back to Python more specifically, I'm going to try to test this Lambda function, which just means I'm going to invoke it. I'm going to have the code attempt to do what it's written to do. And we can see we got an error. And that error is just no module named requests. Requests is not available in the base runtime or the base environment of AWS's Lambda functions. So you have to package requests into the code that Lambda actually runs. So the CLI tool I was using, SAM, when I ran SAM deploy, has the ability to package that into your Lambda function, other dependencies. And it so happens that SAM will by default refer to a file named requirements.txt. I'm sure there are, well, I'm not sure, but I would guess that there are options to point to a different named file, but requirements.txt is the default. And so we can package these requirements into the zip file that becomes what makes the Lambda function actually be able to execute. So let's give that a try. And so there's another command with SAM called build. And I'll run that, and it gives me a build failed. And it says, did not satisfy constraints for runtime, Python 3.11. So let's go back to the infrastructure in our template file. Notice here that the runtime we defined was Python 3.11. Now there are other options. We could change that to Python 12, maybe even 13. I don't know what's currently supported. But the reason this failed is because in this environment, the Python version we're currently using is Python 3.10. So I imagine you can see where this is going. If we can set the version of Python for this specific project to what we need it to be. So let's do Python env, take a look at the versions that are available on the system. So the build error said 3.11 is what we need. It doesn't specify a patch version, so we can use any. So we'll just go ahead and use this one that's available. So pyenv local, and pass it that version. And going back to the project, we can see that the Python version file was created. So that's nice. And, oops. Pyenv versions again. We can see that it's now using Python 3.11. Check the version with Python versions just to make sure, and it looks like it is not using, still on Python 3.16. Okay, it's on 3.11 now. Yeah, I think there's a command you can run to get it to reinitialize, but I don't remember what it was. So for now, I'm just going to not try to dig into that. We'll stay on point. Okay, so we're using Python 3.11 now. That's defined in our Python version file because we set it with Python local. Now let's try to SAM build again. Okay, the build succeeded. And this doesn't matter so much, but there is a new directory that was created called AWS SAM, and this has a bunch of those build artifacts in it. So now when if we redeploy this, so run SAM deploy, it is going to use what is in that directory. All right, looks like it's off. Let's go back to the AWS console and make sure that it's good to go. Okay, so it's updating now, update in progress. Shouldn't take very long because it's still pretty small, even with those dependencies. All right, update complete. Go to the resources again, pop open the function, and we'll test it just like we did before. So all this is doing is just invoking that function, and we can see that this time it succeeded. Hello from Lambda. So that means that it got past the import request, which is what it was failing on before, because request is now available there. So this is handy in my mind because we were able to, define our dependencies in a requirements.txt file, and then have that fit into our application in a natural way where we're building and deploying something, in this case a Lambda function, and it's just picking it up. So as we add more requirements, we can add them in the text file, we can do a pip install and then run pip freeze again and update the requirements file, but we can kind of keep everything in sync and make it clear what dependencies specifically are needed for the application. Okay, so let's talk about a few other tools that are available. I know that time is getting a little short. I don't want to keep everyone here late, so we will go through this relatively quickly. But okay, so pyenv. So right now, the pyenv directory is empty. Pyenv is another tool that you'll need to install from CLI. It's not pre-packed, it's not available with Python installation. So pyenv introduces a little more complex file that stands in for requirements.txt. It allows you to have, or at least more easily, differentiate between application requirements and dev requirements. So pip env, this will initialize the project essentially. So let's say 3.11 and oh, okay, it's because I'm let's try it again. Oh, okay, so we need Python version 3.13.1. Okay, let's go back to our project. And let's just remove the Python version file and check pyenv versions. Okay, we're on 3.12. Let's set pyenv global 3.13.1. Okay, showing 3.13, or yeah, 3.13. Go back to the pyenv directory, and let's try to run that command again. Set the Python version as we initialize pyenv. Okay, so it says it created a pip file. So a pip file is how you track your dependencies and the other things you want defined for your Python project. So we can see here it has this syntax with a few different sections. And then if we run installation commands via pyenv, so invoking them with pyenv and not with pip directly, it will go through the installation and then it will add those to the pip file. And if we run which Python, let's see, I think there's an activation. Yeah, so like I said, when we're running pyenv commands, or these installation commands, you would have to invoke them with pyenv. You can also, if you run pyenv shell, you essentially get a prompt that is inside of that virtual environment. So now, running which Python, I don't know why it's pointing to that one, to be honest. But when we did the installation and when we ran the shell command, another thing you get with pyenv is you get a lock file. So this has more specific details about the requirements of your project. And typically, you would commit both of these to your GitHub project. And one or both would then be used in your deployment pipeline. So, you know, if you've worked with Node, for example, like a package.json and a package lock, similar concept. So, with pyenv, you can export the requirements to a more simple requirements.txt file. And to me, that capability is kind of, it's handy, and it's kind of like the universal translator between these different tools. You can always export how the project is defined in the given tool, whether it's pyenv, poetry, UV. And then once you have that requirements.txt file, it's kind of portable between anything. Now, there will be some gaps. Your requirements.txt file isn't going to have everything in it that the project file had for pyenv, poetry, or UV, but that export capability is really handy. And it definitely fits into a deployment for AWS like we saw with a CloudFormation template and having it just pick up your requirements as a part of the natural build and deploy. So, given that we really only have a few more minutes left, I'll just quickly go through and initialize a few of these projects just so you can get an idea of what they look like. So going into the poetry directory, and then I'm gonna ignore that, I guess. No module name request. Let's deactivate. Try that again. It's possible that poetry needs requests installed. Maybe that's why I was complaining. Okay. Okay, so looking at the poetry directory then, when I initialized it with poetry new and then gave it a project name, in this case demo-po, it provides kind of a starter structuring for your source or implementation files and then your test files. But what I want to highlight is the pyproject.toml file. So UV uses something similar to this. But it's going to give you some things we saw before, like a section for your dependencies and your dev dependencies. It's also going to give you the ability to tack on a version, authors section, description. These can be handy for if you're actually going to build and push a library, like to PyPy, to make it available for others to download. That's been kind of my impression with poetry is it's handy for, or at least it used to be a go-to for helping with packaging and pushing Python projects that are meant to be installed by others. And then lastly, okay, so just empty UV directory. Let's just do a UV init demo UV. All right, initialized. So similar to poetry, it's going to create a new directory. And UV, a couple of observations from me, aside from the one that everyone makes, which is that it's very fast, and that's one of its big selling points, is it's kind of built to be an enhancement to pyenv and venv. It uses those tools to manage the Python version and the virtual environment. And so that's kind of interesting and nice, given that Python itself seems to be starting to use pyenv and venv as sort of first-class citizens. The more recent versions of Python actually ship with venv, like we talked about. So the fact that UV is kind of on top of those or plugging into those naturally makes me feel better about like the long-term compatibility. So I think that's neat. So in the UV project, it uses a TOML file, pyproject.toml file. So I know that these can be pretty, elaborate also. Let's see, UV, I think there's an example in here. Yeah, so this is like a more complex pyproject.toml file, just to give you an idea of what that might look like. Dependencies, dev dependencies, a docs section for like Sphinx, which has like doc creating automation. And I didn't mention this, but I know that UV, Poetry, and pyenv also all support a scripts section, which can be handy. So, and this would be comparable to if you've worked in Node, how you might set up a script section to say like test. So you can do, in that case, npm or npx test. And and then you can define what test will actually invoke. So it might invoke like pytest for a specific file, or pytest with coverage and a bunch of other options. So it's a way to take a longer chunk of code and trim it down so you could just call it with a single, shorter command. So those script sections are handy, and that's available across Poetry, pyenv, and UV, not in the pyenv setup, at least not out of the box. So wrapping this up, yeah, I'll just point to in this GitHub project, there is a comparison here of these different tools, which is kind of neat. We've talked through a lot of these different aspects, but if you're wanting to play around with these tools more, and we're considering some of the trade-offs, and this repo does have information about all of them and some of the pros and cons in the comparison. So, any questions? Yes, sir.
Now you've read about all these ones, do you have one that's kind of your favorite or one that you'd use going forward?
Yeah, sure. I still like to just use pyenv and venv because it's very simple, it's very available, and I like that. So, it's like a typical deal of you kind of like what you know, and I know it the best. In my professional project that I'm working on right now, we actually started using pyenv, and that was new to me at the time, and I was like, sure, I'll give it a try. So learning more about that, it's a little more cumbersome than just the venv, in my opinion, but you do get some additional capabilities, so we'll see where it goes. But I would say definitely UV is the one is most on my radar of going to use this sometime soon. Anyone else? Anyone have anything they wanted to share about their experiences using these? Like, Joey, anything I got wrong about UV that you were just like, that's not right?
I don't think that it builds on top of venv and pyenv.
Mm-hmm.
I know that they've re-implemented a bunch of stuff to be backwards compatible with those, so
Uh-huh.
I can keep the used to them happy.
Yeah.
But that's about it. I have the source code pulled up because I was trying to learn for myself.
Yep. No, that's a really good call out because I don't doubt that that's the case. So like, I think where I got that impression is, like you said, there's so many like compatible commands. Like you do UV venv and you get your virtual environment, and then you activate it the same way by calling a script, the things that we looked at and saw.
I was actually thinking that what you're saying about being built on top of those two, that was more pyenv. So I think that was the idea there. So that was the same guy who
Yeah, that sounds a little familiar. I just can't say, but yeah, I would take your word for it. It's worth like looking into for sure. If, you know, pyenv is utilizing those tools.
And UV's all Rust.
That's my understanding, which is why it's awesome, of course. Daryl, or?
I just wanted to add
Mhm.
one really cool thing about UV. If you've ever had a problem, here's a Python script I want to hand it off to a developer who's not writing Python code or something, and you have to explain how to install Python and all that stuff and the requirements. UV supports inline script dependencies, so you can actually like define a Python interpreter and the dependencies it needs at the top of the Python script, and if you run that, you will automatically install it's really convenient for handing scripts off to people who aren't Python devs.
Okay.
You think that they're going to be as good at installing UV as they would be Python?
So the comment in the audience was something like if you can have a Python script with a definition at the top, which UV can then use to help set up the environment. Is that accurate?
Yeah, including installing Python interpreter and Python dependencies.
Okay, including installing the Python interpreter and dependencies. So I haven't seen that, but that sounds cool. Daryl?
Yeah, I think when I was looking at UV earlier this year, what I thought the best part of it was just, when you're going from project to project, you're getting into, like, today you're working in Java, tomorrow you're working on this project in Python, tomorrow, next day you're working in TypeScript. And the next time you get around to another Python project, it may be on an older version of Python or a newer version of Python. And when you're using, pyenv and all that other stuff, you have to set that up yourself. You actually have to go look in the files and set that up. But it's my understanding, if you have UV installed, you pull down a project from GitHub, and you go in there and you do UV whatever. I can't remember what the command was. It would just, if you didn't have that Python installed, it would install it. If you did, it would select it, and then you would just be all set up. And so that just makes it so much easier when you're switching contexts.
Mm-hmm.
You don't have to remember your stuff. I can still remember having to look in the AWS file to see what version of Python I had to make sure I'm working with, because that's what AWS requires.
That sounds really familiar, because recently I've been going through a lot of, doing a lot of certification in AI and Ed Donner's courses. Familiar with him, but he's UI, I think it's UI install might be what you were looking for, but yeah, I just run that, everything's set up, and I don't have to worry, don't have to touch that.
Mm-hmm. Yeah, it's cool. Yeah, it's definitely something when you experience some of the pain, then you appreciate what these tools actually do for you, versus if you haven't experienced that, it's just kind of like, isn't it more work than I need to do? Anyone else? All right. Well, thank you for taking the time and coming to see my presentation. Appreciate you showing up. Apologize for the places it sucked, but hope you got something out of it.